I'm Jose ALCÉRRECA.
And I'm WOJTEK KALICISKI.
And I'm FLORINA MUNTENESCU.
And thanks for coming to Now in Modern Android. We've been talking about modern Android development for a while. So you might be thinking, is it still modern? Well, yeah. Android development is a moving target. It's an ever-changing system. And the reason is that your users' expectations have grown. They expect more features, deliver faster, or more form factors and devices. They expect their data to be synchronized across devices, and they expect emojis to work everywhere. And another 1,000 things that were nice to have just some years ago. Because of this, and to make your life easier and improve your productivity, we're constantly evolving the tools, the guidance, and the APIs. And this means that some APIs get deprecated, some APIs might look duplicated. Also, are you supposed to use fragments with Compose? Should I still use live data? Years ago, a single developer could build and maintain a whole app, but nowadays there are so many features and areas, animations, testing, design, build, infrastructure. And it's hard to be an expert on all of them. So it can be hard to keep up. What are we doing about this in modern Android development? One solution to this struggle is opinions, having opinions. Android used to be a bunch of platform APIs and reference documentation, and it didn't come with lots of recommendations or opinions. The truth is, most of the time, you're doing something that has been done a million times. And I'm not saying your app's not special, it really is, but why reinvent the wheel? For those cases, we try to provide a good opinion, something that fits most situations and it's easy to use, either through libraries or guidance. So that's the idea behind modern Android development, being more opinionated and supporting those opinions through code, tools, and guidance. This makes it faster and easier for you to build apps, and we've been applying this idea. So how can a library be opinionated? So take, for instance, Hilt, our dependency injection framework. It's much more opinionated than, and tailored to creating modern apps than Dagger, which it's based on. For instance, it knows about activities. With the Android entry point annotation, you can enable members injections. Also, because it's recommended, we can add support for it in Android Studio. You can find all the consumers of a provider just by clicking on the gather icon. And also, we can add APIs to Compose so that they work really well together. So how did we get here? Well, Jetpack evolved from the support library, and that was created to address fragmentation as a way to unbundle functionality from the platform. Then we added new libraries like Recycler View or data binding. And in 2016, we released Architecture Components, our first collection of opinionated libraries. A year later, we grouped most unbundled libraries from the Android team into Jetpack, and today there are more than 100 libraries and more than 200 contributors, which is mind-blowing. One nice thing about Jetpack is that if you ever need to deviate from those opinions, you can always do it. Just move to a lower level. So they are recommendations, opinions, but not commands. So during the past 2 or 3 years, it's been hard to follow everything that has been going on. And if you haven't been paying attention, well, we don't blame you. Now that we're back in person, in this talk, we'll look at the most important things that have happened in recent years, and we'll show you how we implemented them in an open source app called Now in Android. Now in Android is a blog and YouTube series that provides the latest developer news from the Android team. Now it's also an app that gives you access to the same content. And it's also our new sample, showcasing all our opinionated designs and solutions and the latest guidance. You can find it on GitHub, where it has already gathered an amazing developer community. So let's see how we used the opinions in modern Android development to create it, starting with languages.
Thanks, Jose. So as a warm-up, let's start with an easy one. What's the first question you ask yourself before you write even the first line of code? Anyone? That's a nice one. But we've seen it over and over again on developer forums, Twitter polls, everywhere. The question is, of course, Java or Kotlin. And I think, well, I hope this audience already knows the answers to this question, but I feel like it needs to be said again. Our opinion is that you should use Kotlin to build apps on Android. Since its introduction as a supported language on Android over 5 years ago, we've made it ubiquitous across our documentation, samples, and even APIs. And this is perhaps the most visible in the latest Android X libraries, which are actually written in Kotlin. And not only they're written in Kotlin, they also offer first-class Kotlin-based APIs. And even some of the older libraries we are rewriting in Kotlin while maintaining API compatibility. And why are we doing this? For the same reasons that we're recommending Kotlin to you. Our engineers are just more productive when they work on Kotlin code. We've also found on play that apps generally crash less if they're written in Kotlin. And finally, Kotlin lets us use modern constructs such as coroutines, which is the modern way to handle asynchronous operations on Android, both internally in our libraries as well as in APIs that we offer to developers. In fact, we like Kotlin coroutines and flows so much that we've made it our recommended way to handle asynchronous operations on Android. Basically, to help newcomers choose the right solution, as well as to steer the library ecosystem in the same direction so that you don't have these competing solutions, although you still can choose them if you want to. So we're here to talk about what's new in modern Android development. And all of this maybe was already known to you. But who here has heard of KSP? OK, quite a lot. That's good. So its full name, Kotlin Symbol Processing. And if you've ever complained about long build times with Kotlin and went in to examine your build, you might have found that the Kotlin annotation processing tool, CAPT, was maybe the culprit. KSP is still a fairly new, lightweight API for building compiler plugins that is supposed to replace KPT. If you're building apps, be on the lookout for libraries that are compatible with KSP. One of those is Room, our own database library. And for an app developer, it's really easy to start using KSP by changing a few lines in your build Gradle file. And if you do that, you will see quite significant improvements in your build time. Now in Android, we only have one simple module that uses KSP. So if you look at absolute times, maybe it's not mind-blowing. But as more libraries migrate to KSP, you will see significant improvements. Now, the takeaway for library authors is that KPT is in maintenance mode. And KSP is now the official solution for annotation processing in Kotlin. So all libraries should really migrate to it. Unfortunately, for libraries, it's a little bit more difficult to migrate to KSP than just a single line change. That's why it'll take some time until we migrate our most prominent libraries, like Dagger and Hilt, for example. OK, I'm almost done talking about Kotlin. But if I had to pick one reason why we recommend Kotlin to you as a way to build Android apps, it's probably Jetpack Compose, our first Kotlin-only library. But to talk about Compose, let me invite the experts. Florina?
Thank you.
Getting a clap for you. Nothing.
We launched 1.0 of Jetpack Compose, our modern declarative UI toolkit, last year. And since then, we've often been asked, should I use Views or should I use Compose? Compose is stable and ready to be used in production. It already covers a broad feature set. So if you're just learning Android, use Compose. Earlier this year, we actually released an Android Basics with Compose training targeted to folks that are just learning programming. If you're building a new app, use Compose. If you're building a new screen, use Compose. So then, you might be wondering, where should you use Views? Well, I think that, first of all, no matter where you are in your learning journey, you should be using Compose, because any code you write with Views will become technical debt. At the same time, we know that we are still working on some advanced features, like staggered grid or text auto-sizing. So if you need a feature that can't be implemented with Compose, that's the part where you'll have to use Views. Otherwise, please use Compose. But what I think it would be even better is to check out the roadmap. See whether the feature that you want to use is there or not. And then if it's not, please create a bug. We want to make sure that whatever was possible with Views is also now possible with Compose. So then, it's not really, should I use Views or should I use Compose? but rather, should I use only compose, or should I use views and compose? OK, so why do we recommend building with compose? We believe that compose allows you to write less code and accelerate your development. It's intuitive and powerful. But don't take my word for it. Let me show you compose in action from now in Android. So the first thing actually I want to show is just how expressive compose is and how you can do a lot with a little code, which makes it easier to understand and to maintain. So what I have here is the For You screen. It's the one where you can select the topics that you're interested in, and then based on those interests, you get a feed. Let's see how this was built. So first of all, I have a Now in Android gradient background. And then on top of it, I have a scaffold. So this is the one that provides the layout structure that allows me to add components like a top bar. In the top bar, I'm setting the title and the navigation and action icon. And then inside the scaffold, I'm setting the content. In this case, I have a lazy column. And then the lazy column has a modifier that's called fill max size. What do you think this does? It tells the lazy column to fill the entire size of the available space. And then inside the lazy column, I have two things. I have the interest selection and the feed, so two elements. And here I have a lazy column. So this means that these items will be displayed vertically, and each item will just expand as much space and take as much space as it needs. So with very little code, we implemented the basic structure of this screen in a recycling list of content. It's just so easy to understand how the content is laid out. OK, let me show you one more thing. So this is the author screen. And an author may have a bio. OK, so then how do we do this in Compose? It's just an if. If the author has a bio, display the text. There is no view visibility gone or invisible or whatever. With so little code, you can do so much. There is no XML, no layout manager, no adapter, no other files to jump into. Compose is just so easy to understand and to maintain. But I think Compose is able to be so expressive because of the opinionated way its API is built. So Compose APIs themselves are opinionated. Even more, we released a set of Compose API guidelines that enable you to write idiomatic Compose code. So we know that composables should be small, focused functions, so they're easy to be reused. So this means that these would be top-level functions that you declare in your files. Because they're just top-level functions, it means that they don't belong to a class, to an activity or a fragment. So you can build single activity applications. So this means that with Now in Android, for example, we have a main activity. It's actually its only activity. And what we do here is just call Now in Android app, which is the root composable. And that's it. That's the only thing we do in the main activity. So this means that all of the other composables can be reused and are separate from this. But if you're thinking about migrating to Compose, you probably have a multi-activity or fragment app. Don't worry, you don't have to throw away all of that code. Compose works in these scenarios as well. Even more, in our Compose samples, we cover a bunch of these kind of use cases. So what's more, if you're thinking about migrating to Compose, you can interop between views and Compose. You can call Compose from views or views from Compose. And even more, libraries and APIs that you expect to work with Compose, like viewModel, navigation, content coroutines, do integrate seamlessly in the Compose world. So you can migrate when and where you want. Another place where Compose is extremely opinionated is in the UI components it provides. Compose offers an implementation of material design out of the box. So switches, text fields, buttons, all of these are material components. All follow material out of the box. There is no non-material button. You get full support for material to components. And we'll soon have the same level of support for Material 3 with new and improved components and dynamic color. To reflect your product's brand in your app, you would customize things like color, typography, and shape on the material theme. And then, when Compose renders those components, they will use the values that you set as default values. But while Material is a recommended design system, you can customize it even further if you need. So to do that, there are multiple ways that you can do it. You can extend material theme. You can replace the material system. So for example, you can replace colors or typography or shapes with your custom one and then keep the other ones as they are. Or you can go fully custom with a custom design system replacing the material one. The Now in Android app is primarily based on the Material 3 design system, but it customizes some components and uses gradients. So one of these components that's customized are the filter chip. So here we have different type, color, and border. Let's see how we implemented this. So what we did is we took the filter chip for Material, and we wrapped it inside our own Now in Android filter chip. And then we set a bunch of defaults that follow our design. So we set the selected icon, we set the shape, we set the label typography. But what I like about Compose is that you can go even more custom. So for example, you can override the filter chip default colors. And it's incredible. Like the filter chip color contains stuff like container color, label color, disabled color, pretty much anything you need to customize this as you want. So what we've done here, we set the custom colors for color and for border, and we implemented our design. So Compose is not opinionated only in its components, but also when it comes to building for layouts, for large screens. More precisely, we recommend building responsive UI to ensure that your app looks good, no matter what device it runs on. Compose helps with building top-level adaptation and with building responsive components. It makes it easy to change what you show based on the available space. So for example, Now in Android, we switch from a bottom navigation to a nav rail for larger screens. So to implement this, you just use an if statement and use the composable that suits your needs. It's also much easier to build components that adapt to the available space, not just to the screen size. So for example, you can change the number of columns that are displayed in using a vertical grid. Compose just makes it so much easier to adapt your UI using the Kotlin control flow. But now, we looked at UI. Let's zoom out a little bit and look at some recent changes in architecture.
All right. Now for the fun part. So in architecture, we got a lot more opinionated. The official architecture guide is the result of months of debate and bike shedding. It contains recommendations that work well for the vast majority of apps, making them scalable, maintainable, and testable. The new guide has lots of opinions, but ultimately, we base them on a bunch of common software engineering principles, like separation of concerns, so you don't stick all your code into the main activity, driving the UI from data models so that data is not lost when apps are restarted, having a layered architecture with clear, well-defined interactions between the layers, using a system to manage dependencies. Android apps can grow really quickly, so using a dependency injection framework is now a recommendation, even for small apps, and more opinions, like making each part of your app testable, because adding tests cannot be an afterthought. It's hard to test something that wasn't designed with testability in mind. So we divided the architecture in layers, the same way we recommend you divide your app. So let's start with the UI layer. This layer gets data from the other layers and renders it on screen. It's also called a presentation layer, and the UI is actually just one part of it. A lot of the heavy lifting is done in your stakeholder, which is normally a presenter or a view model. For the UI layer, we also have some opinions in the guide. How to define the state of the UI. We talk about immutability. We talk about this thing called unidirectional data flow, which I'll expand on in a minute. How to expose state to the UI and how to consume it from it. and many other things like recommendations on threading, navigation, paging, animations, etc. OK, so moving down, we have the domain layer, which is optional, so we're going to skip it. But check it out, because it's a very nice way to reuse business logic. And then we have the data layer. The data layer contains application data and business logic. Business logic is what gives value to your app. It determines how data is created, stored, and changed. It's made of repositories that each can have or depend on 0 or more data sources. Basically, you should have a repository for each different type of data that you handle in your data layer. So if you, in the case of now in Android, we have an authors repository for authors and a news repository for news. OK, so in the guide, you'll find a lot of recommendations. It's a very long article. But for example, uses suspend functions for one-shot operations. Yes. OK. Kotlin Flow for exposing streams. This is a big deal. Also, we have some naming conventions that you can use in your app, threading and lifecycle considerations, how to model your data, and how to expose errors to the UI layer, and a lot more. Manuel Vivo is giving an architecture talk tomorrow where he goes into detail about all the new recommendations. But I'd like to highlight one that shows very well how we evolved the APIs and the guidance with them. It's the UI layer events. UI layer events originate either in the UI, when the UI needs to send an event to the view model, or in the view model when it needs to send an event to the UI. UI events are very easy, because normally you have a reference to the view model laying around, or it's easy to get to it. So you just call a function. The function is called once, and it's received once. That's easy. However, things are more complicated when we try to do it the other way around. View models don't have references to UI elements, at least not anymore. That's a very dangerous practice from the days of Model View Presenter. These are events that only need to be used once, like showing a snack bar or sending a navigation event. The TLDR, the summary of the recommendation, is that you expose this event as part of your state, and if needed, once consumed, you reset the state, sending an event back to the view model. What does this exposing a state really mean? Well, instead of exposing events as command, you expose them as state. Instead of sending a single command to the UI to tell it to show the loading spinner, you just expose state saying that data is loading. Instead of commanding the UI to navigate to the home screen, you just tell it that the user is logged in, and then the UI will decide to navigate or not. But what if you need to reset that state? Let's look at the canonical example, which is snack bar messages. So we start in a composable, where we observe the UI state. This UI state would be a compose state, something like that. So you don't need to collect it or observe it. It's pure magic. So if there's a user message, then we grab it, we start a coroutine, and we show the snack bar. This is how it's done in Compose. And it's super cool, because this method suspends until the snack bar is either dismissed by the user or it times out. So we know that after this method, we can tell the view model that the user message has been shown. We send an event back to the view model, so the view model can reset that user message. So solutions that we have recommended in the past are no longer fitting, like single live event and event wrapper, especially in Compose, where certain practices are easier to spot as a smell. The difference is subtle, but very important. Those methods were making you expose mutable state. In that way, the UI could read and reset the state in a single operation, which was convenient, and in principle, it's not a wrong approach. I mean, if you ever use data binding, that's exactly how two-way data binding works, using mutable state. And a lot of very successful frameworks work this way. Actually, it has a name. It's called bidirectional data flow. However, to make things more robust, especially in the Compose world, our recommendation, our opinion, is that you should use unidirectional data flow. Immutable data is exposed, and then user events are sent to the view model, where state can be mutated. Obviously, UDF is not restricted to the UI layer, and the source of truth and it does the loop with a source of truth, whatever you want to put it. This is the general idea of UDF. Now, in Android, we follow UDF everywhere, and the source of truth is usually in the data layer. You can check out any view model to see how the mutable streams are coming from the data layer, are combined into a UI state, and it's exposed to the UI. And then all user events are passed to the data layer, if needed, depends on where the source of truth is, through the view model. OK, so we said that one of the main reasons why we follow good architectural practices is to make our app testable. So let's take a look at some testing opinions. And the first opinion is that you should test. Testing is a small investment compared to the huge productivity boost that it provides long term. As you can see in this very scientific chart that I just made, it's been actually a very exciting couple of years for testing. We have new testing tools, new official guidance. Compose happened, which was a big deal. We'll get back to it. And but Compose is not the only library that has made testing easier. So let's start with that one. The Jetpack developers have been releasing testing artifacts to help you test your code without having to resort to complicated mocks or adding more levels of abstraction. For example, fragment testing lets you launch fragments directly on empty activities. Navigation testing lets you navigate directly from tests. We have room testing that provides a migration test helper. Window testing helps with foldables. And Media 3, Where, Work Manager. We're making sure that every library that is released comes with a good testing story, either by having testing artifacts like this, or at least with proper guidance. However, code that uses libraries should be easy to test without any testing artifacts. Some of these artifacts are actually only needed in edge cases or complicated situations. So always check out the documentation to see if you need it or if they are available. In fact, we don't use most of this now in Android. For example, we start all our navigation tests in the start destination, and if you do that, you don't need the testing artifact. All right, so coming back to Compose, this is the biggest thing that has happened lately for UI testing, and for testing in general, I'd say. All APIs in Compose are designed with testability in mind, and that has opened the door to new types of tests. For example, with Compose, you can create this, what I'd like to call a unit UI test, which is kind of an oxymoron, so a very small UI test. That lets you focus on a very, very small composable. And you can forget about starting activities or creating complicated dependency graphs. You can create super focused behavior tests like this one, or you can even run simple checks inside a composable. In here, the Now in Android theme is tested to verify the color scheme when dark theme is false. How would you even do this with views? So the testing cheat sheet is a good summary of all the available APIs. And if you want to start right away, you should check out our code lab and the documentation at Google Compose Testing. All right, so the Now in Android app has a typical testing story. View models are unit tested, and the data layer as well. All features have UI tests with Compose APIs. We also have some smoke UI tests to make sure that all the happy paths work and they don't crash. And there are more unit and integration tests for things like data migrations. Now, there's one thing that I think is going to be very, very important in the near future, and that's screenshot testing. It's not a new thing at all. However, in Compose, because we're using composition and not inheritance, there's no concept of a background color or a corner radius, at least of a composable. So if you need to test visual elements, you should consider using screenshot testing so that you can catch regressions and also do compatibility testing across devices. Now in Android, we're exploring this with libraries that have been popping up, and we'll probably start using them soon. For example, there's a PR to add screenshot tests using the Paparazzi and the Showcase libraries, which is super cool. But that's all I'm going to say about testing, because if you want to learn more, Yolanda and I are talking about modern testing strategies this afternoon, including tooling, Compose, screenshot testing, etc.
Yep, I think we can all agree that testing code is essential to your app's success. But you know what another measure of your app quality is? Well, it's on the screen, so you probably know already. Yep, that's performance. And app startup time, smooth scrolling, fast response times, these are just some of the metrics that your users really care about. And so it's not just our opinion that you should care about performance too. In fact, you should treat performance just like your regular tests. Your job is not done once you get them to a green state once. It's really all about understanding your metrics, constantly monitoring for regressions, and fixing those. So that's why now in Android, we've integrated the macro benchmark library to help us understand how we're doing on app startup times. Probably one of the most important metrics that can make or break the first impression of your app. Macro benchmark can also help you with a few other things, such as measuring jank and response times in common user journeys. However, I'd like to talk about one feature that can have a real positive impact on your app's performance, and that every app out there should start using it. The thing I'm talking about is called a baseline profile. And we're using macro benchmark now in Android to generate one. Now, we have a whole talk at this conference about how to create benchmark profiles and how they work. The short story is, use a macro benchmark test to automatically generate a baseline profile for your app. And it traces every method that is run during your app startup, then saves it to a file. Then that information is used to optimize that code during the installation or first run of your app. Whenever the user first taps on your app after installation, they get up to 30% faster app startup just by adding a baseline profile. No real coding or production code changes required. So if there's one thing to take away from this section of our talk, that's to go and add baseline profile generation to your build process. It's really the low-hanging fruit of app optimization. And speaking of build process, it's what you do tens or hundreds times a day to see the code changes you made in action. Well, this needs to be said, unfortunately, but we weren't very opinionated on what you should be doing and should not be doing in your build files. And the fact is that you can put any Groovy or Kotlin script code in the build file and make it work, right? For better or worse. And as our apps grew and builds became more and more complicated, so did build times, and build speed became a real issue for developers. Fortunately, Gradle came up with new features and optimizations to counteract that growing complexity. But it also made it more difficult for us, because it put more constraints about what we should be doing and should not be doing in our build files to keep those builds fast. That's why from Android Gradle plugin 7 and onwards, we started really focusing on building new APIs and modernizing our DSL to make it less error-prone, easier to use, and to help keep developers on the right track. We're also coming up with more opinionated guidance, and we'll be updating our documentation and adding more build recipes to our GitHub pages soon. One topic that I want to talk about today is the declarative nature of build files, and what to do with complex build logic that you will ultimately probably have in your build at some point once your app grows. When I say declarative, I mean that your build files should really just contain a description of your build configuration. And they should be free of any statements that can be executed to perform actions, as they can clutter your build files, and my slide, and make them simply unmaintainable. And to help you achieve that, most plugins give you special DSLs through their extension objects, like the Android block here, to help you configure your build and keep it declarative. In fact, it's easy to identify the parts that you should be touching from your build files if you look at our reference documentation. They're all in the DSL package. Everything else in the API packages, if you need to access that, you're probably better off putting it in a custom plugin in your build SRC folder or in a separate project. That way, you keep the separation between your build configuration and code, which additionally should be tested probably, making everything much easier to maintain and less likely to create problems along the way. Now in Android, though, we had a slightly different case. Now in Android differs from our smaller samples in complexity. It has many modules. The setup is much more complicated. More people are contributing to it. And not all of them are build experts, right? At the same time, if you look at the build files, there's a lot of duplication between them. Most of the modules are configured as libraries. Many of them depend on a common set of core utilities, and all of them probably need Kotlin. Normally, you would configure all of that in the build files using the DSL, as I just mentioned. However, as the project grows, you might find it useful to centralize all of that configuration in so-called convention plugins. And that's what we did. Convention plugins have no special powers over normal plugins. It's just a name. In fact, most of the ones we created are very bare bones. They only apply other plugins that actually do stuff and configure them, such as for Android library here. And because we made all of our convention plugins with a single responsibility in mind, they're also composable. So it's easy to pick and choose the features that you want for a module. Engineers on our team working on the sample don't need to know how to configure things and what the actual magic incantations they need to put in the build files. They just pick the modules, pick what they need, and it works. They apply the set of required convention plugins and get back to working on application code. If any changes or fixes need to be made in our config, the build experts on the team can do it once, and all modules get the benefits automatically. So that's quite handy. While we've not made this our official recommendation yet, especially because it may make sense only for a certain size of projects. So we might not want to introduce across all our small samples, especially for beginners. But we are actively using this setup now in Android, and it works for us. So we are evaluating it for making it a recommendation for other apps as well. And by the way, I also want to thank everyone in the community who's written great articles on this topic. We're learning a lot, we're being inspired by them, and they're a great help for anyone who wants to learn about build, so thank you. One more thing on the build duplication topic. We're introducing a new settings plugin in Android Gradle plugin 7.4 that you apply to your settings Gradle file, not to your build file. And it basically lets you configure certain configuration options across all your modules in this one place. We're starting small with compile and min SDK, but we'll also be adding custom execution modes for CI and local development that will help with managing the performance of your builds. And finally, let's talk about dependency management, also a hot topic in the build world. So that means how to specify all of the dependencies and versions that you need for your project to build. Historically, we've seen this done in multiple ways, and even our samples were inconsistent. Some of them used extras properties on the root project. Others wanted a more compile time safe way of specifying stuff in a class in a build SRC file. There were other solutions, but all of them had flaws, and I mean all of them. But at the time, there wasn't anything better, right? Fortunately, there's a new feature in Gradle, new-ish, called version catalogs, which lets you declare all the versions and dependencies in a simple text file in a format called TOML. And then it generates type-safe accessors that you can use in your build files. It greatly simplifies dependency management, as we've seen firsthand from using it now in Android. So if this solution is so straightforward and great, why didn't we, again, implement it across all our samples? We will. But first of all, this is a fairly new solution. It was experimental until recently. And second of all, it's not yet supported in Android Studio, unfortunately. So things like AGP Upgrade Assistant and Project Structure Dialog will not work if you have version catalogs. The good news is we believe that version catalogs are the way forward for the whole ecosystem. So we are working to introduce support in Android Studio, and we will make it our officially recommended solution. So don't worry about starting to use it today if you choose to.
From architecture and testing to build and performance and Jetpack Compose, modern Android development is a set of opinionated APIs, tools, and guidance to make Android development faster and easier. But more than anything, modern Android development allows us to create a common language, a common set of expectations and defaults. So whenever we say repository, we all know what we mean. You don't have to follow our guidance to the letter. You can deviate from it to whatever fits your app But by having this common language, this common set of defaults, it means that it's going to be easier for anyone joining your project. Modern Android development was created because of you and with you. We listen to the problems you have and try to address them. We listen to the best practices you converge to and try to support them. And we're not done yet. We want to know how else we can make Android development better. So join the Modern Android Development panel later today. Let's make Android development better together. Thank you.